Okay, so Python Dunder methods. Does anyone know what that means?
There's a double underscore before it, and it is special for some reason, like the init method.
Yeah, so there's double underscore both before and after. So if you just have a double underscore on the, on the front, that's a little different. But if you have a double underscore under both, then yes. So they're special and they have underscores. Does anyone else have any other thoughts or maybe
I
guesses?
assume they're just part of the Python library that you can access, like the classes that are already part of the Python library that you can tap into.
Yeah, so they're special methods and they are basically part of Python. So we've seen classes, right? So we've made lots of classes, and you can make your own classes, you can have your own methods and your own attributes. You can make it totally customized. And when you use inheritance, for example, you can override or customize a method that you've written in a base class. You can also use, you can also do the same for these built-in methods that Python supplies. So when you do something like, so if I do x equals, right, I have a list and I do len, something like that. Oops, I should print it. Great. So the way that you use length is kind of a convenience. So under the hood, this X is actually an instance of a Python list. So it's an instance of a Python list class, and there's a method that you can call on this class, this list class, that will return the length of the list. And print actually will access another method called str. So double underscore str. Length uses double underscore len. So Python will, under the hood, actually use these double underscore methods for a lot of basic functionality. And it's not just limited to these two cases. There's a whole bunch. The plus. So if I do 3 plus 4, or 1 is greater than 2, whatever I'm doing, these will usually get evaluated as Dunder methods under the hood. So let's go ahead and make our own class, so we can start playing around with some of these just to see how they work. Because it sounds very kind of bizarre and intimidating, maybe initially, like there's these special methods and they have double underscores and everything, but they're really just methods, and you can override them and interact with them just like anything else. So let's make a class. So what's the first thing that we almost, 99% of the time, what's the first thing we're going to do when you create a class?
Write the constructor. So like the def init.
Okay. So def init. So what I'm going to do here, I'm just going to, we're going to end up doing a lot of print statements here, but print right, I'm going to create an instance of the class. So this method gets called. Now it's not really doing anything, right? But this is getting called. So there are actually a whole bunch of, when you create an instance of a class, so far we've only seen this one, and this is really the only one we need to worry about. But there are a couple other methods that also get called when you create an instance. So you can think of this as almost, there's kind of like a life cycle for creating a class. So you have constructors, you also have basically a destructor. So if you've worked in other lower level languages, you have constructors, you also have destructors. We don't have to worry about that in Python, but so there's another Dunder method, which is called new, which will actually run before init. So new will actually create the instance, and then init will run basically whatever customization you need. So all these Dunder methods will, they have their own inputs and outputs. So if you want to learn specifically how to use one, you'll have to look it up. But this one is new, and it will take it takes the class, and then just to make this flexible, you don't really need to do this right now, but args and quargs. So this will just be, in case we're passing in anything else, we'll go ahead and grab that, and then we'll return. This particular method requires you to return something. So we'll return all right. So we run this, and we can see that, the order that I've defined this stuff doesn't matter. So all I've done is create an instance, and under the hood, even though this wasn't necessarily visible to us before, under the hood, Python is running new. It runs this Dunder new first, and you can, hook into that if you want to add any customization. After it runs new, it will run init, and again, you can hook into that and run any customization that you want for your instance.
So Chad, what is that .args and that .quargs? What does that mean?
This basically, so the specific name args and quargs it's just a normal variable name.
Okay.
So it's just conventional to call it args and quargs, but this asterisk is part of Python. So this basically will allow you to accept a variable number of positional arguments. So if I don't know how many, so for example, if I write a function, right, I can say, A and B, right? So I know that I'm going to take two parameters, and I'll do I can do something like this. So not the most exciting function. So if I run this, I can print 1 and 2. But it might be the case that you want to write a function where you don't want to explicitly determine the specific number of parameters that it takes, right? So like the print function, for example, in Python, the print function, you can pass it no parameters, or 1 parameter, or 50 parameters, right? So an alternative to doing this is to say, we run this and we get the same thing. So I can add so this is just going to basically scoop up whatever gets passed in as a positional argument. And this, the two asterisks, well, the keyword arguments. So if you do something like so if you did something like I'm not sure if print will, yeah. So this won't work with print, but we could do something like, yeah. Anyway, we could play around with this, but the point is that this will allow you to pass in any number of positional arguments or keyword arguments.
Should there be a second asterisk in line 10 in front of quarks then?
Yes, there should be. Thank you. So we're not passing anything in, so this actually doesn't matter. This is just a way to make it more generic.
And for this Dunder new, you don't have to put in self, I'm noticing.
Yeah, so new will take, it takes the class as the first parameter rather than the instance. That's just how new is.
So is it taking in my class there? Does it know to take in my class, or do you have to hook that up somewhere?
No, it just like self, you don't have to explicitly pass in self. When you call a method on a class, you can specify, you can pass it in, but you don't have to. So Python under the hood will do that. So it's the same thing here. The first parameter, Python is passing that in. So you're unlikely to ever need to use this. I'm just showing you that there is a life cycle here. So when you create an instance, even though, we didn't see this run before, right? But this actually got run anyway. It just got the whatever we're inheriting from, which implicitly would be object in Python. You don't have to specify it. But objects new Dunder method would get run. But here we're overriding that. And so we can actually see it get called. But under the hood, Python is going to call these things. So there's another, so these two will get called when you create an instance. When you delete or when an instance gets deleted, there's another one that gets called. Oops. This one is a little trickier because so does anyone have any ideas as to what happened? We see that new got called, init got called, and then delete got called.
I assume since your file finished running that it disposed of that instance.
Yeah. So has anyone had to deal with explicitly like garbage collecting or managing memory or anything like that? So neither have I, unfortunately.
Little
But okay. So can you tell us if you know, if you don't mind, just maybe what garbage collecting is?
Garbage collecting is basically freeing up memory that's been used by object instances. So once they've gone out of scope or once they're, destroyed, then that memory is available for other things.
Yeah. So if we create a variable or something, right? And then we run our file, and then maybe there's no other references to that variable, or we're not using it anymore, we delete it or whatever. Instead of keeping that memory occupied, Python will runs a garbage collector, which basically will look for dead links, essentially. So it'll look for dead links, and if it sees that, hey, here's a value, but it's not connected to anything, there are no references, in the scope anymore, it'll delete it for you. So in lower level languages, you have to do this explicitly yourself. You have to allocate memory and then deallocate memory. But Python takes care of this for you. So the reason this is called, even though we didn't explicitly delete it, is that we ran the file, and then this is not being used anymore. So I believe that you can't really directly call this. So this is just what gets run when it's garbage collected, and when it's garbage collected is going to be not entirely determined by you. But anyway, the point is that we can see that there's a life cycle. All I've done is create an instance, but 3 built-in Dunder methods have been run. And because we're overriding the built-ins, we can actually see them get run. Okay. So this is, in terms of like life cycle, this is the basic life cycle of an instance. So we typically only care about init. So something gets created, it's probably just going to get created. We don't need to worry about that. And then when it's initialized, this is when we add our attributes, whatever values we want to have. We can run other methods in the function just to get things set up. So whatever's in here is going to get run when this init function gets called automatically under the hood. And then delete, again, this is not something you're probably ever going to have to use, but if there was ever if there's any cleanup that you needed to do, depending on what you were doing, maybe closing a file or something like that, you might want to hook into that and then customize what happens when it's deleted. Okay. So there's also a whole bunch of other things. So another common one, so there are 2 Dunder methods that you should know about. One is init, and the other is str, string. So does anyone have any idea what the str Dunder does?
Does it get called every time you make a new string?
Every time you make a new string. Could you elaborate on that a little bit?
Like if you are, let me think, like if you are, for example, making a variable that equals my string, would it get called that in that case?
So it wouldn't get called when you create it, but it would get called, for example, if you tried to print. So if you ran print.
So every time you use a string in something?
So this will be the representation, the string representation of your instance. So this class doesn't have to be a string. This might help since this class is empty. Let me see. Okay, so we can think of, so my class now is this data attribute, which is an array, right? So it's not a string, it's an array. But if I want to print a representation of this, so I could do something like I can just do this actually. And this will by default give me, let me comment that out for a second. Right here, this will be the default string representation that Python gives us. So when we try to print, again, under the hood, Python is going to call the Dunder str method for the object. Since we haven't overridden it, it's going to go up to whatever our base class is, which in this case is just the object. So it's going to call that, and we get this, kind of interesting, but maybe not so helpful string representation of our instance. If we want something that's a little more useful to us, let's say, instead of just the memory address and so on, we can return a value that will be useful for us. So this can be anything, but we'll just return and we'll do so now when I print, instead of getting this thing, which comes from object, we get the specific thing that we get the specific custom behavior that we added here. And it would be the same thing if we do let's see. So here we're calling print on the instance itself, right? And because we've overridden the string Dunder, we'll get this custom thing. But calling string on this instance will also do that. So again, this function that we have in Python under the hood is really calling this. Are there any questions about that so far? So again, I'm just, this is mostly just exposure. What you'll actually end up using is init and str. Okay, there's a whole bunch of other ones. Let's look at a couple more real quick. So def get attribute. So for get attribute, this will be called when you try to access like dot. So whatever dot whatever. So I'll call MC dot whatever. And we see get attribute is called. So what would happen if I tried to do this without overriding the get attribute Dunder?
It would say that the attribute wasn't found.
Yeah. You get an attribute error. My class has no object. So it, we could deduce that the object's get attribute Dunder is doing some kind of check, and it's going to throw an error if something isn't found. So we could kind of imitate that. Let's do. I'm just going to copy this. So we can see that get attribute is called. So, and then we can see that we get an error. But this error this time is coming from our own subclass. So if we actually wanted to customize this, it would be a little bit more complicated than, let's say, the string, because we'd have to do some kind of checking, and we have to look and see if our instance has the property, and so on. But now, even if we don't have it, it's not going to throw an error. Okay, and then there's I'll just show you one more real quick. There's get item. Oops. It should be the index. So get item is going to use brackets, like in an array, if I want to get the third element in an array or something like that. Get item will work. So obviously we don't have anything. This doesn't really make sense, but it will still get called because we have overridden it. So this is one of the, I think, cool things about Python is you can create your own class that behaves just like a built-in Python class. Now that may or may not be useful to you, but it's something that's available. So you can write a class that works with the dot notation, and works with the plus sign, the plus operator. It works with brackets and a for loop, and all kinds of other things we haven't even talked about yet.
And it looks like for that get attribute one, like you could specify that only to work when you're using the ASDF attribute by passing that into the attribute. Is that how that would work?
Yeah. So I mean, what you would act like if this were actually a sensible implementation of this, what you would do is check the attribute, check if it's like on the instances. It's a property on the instance, which you could use like the Dunder dict or something like that. So the dict in order to check that. And if it's there, then you can return that attribute. If it's not there, then you throw an error. Or you could do whatever else you want, but that's basically what the Python implementation is doing. So you could just do like really random wacky stuff if you wanted to. I mean, you wouldn't really want to do that, but you could. Okay, so this is Dunder. So the Dunders are just kind of basically built-in methods that you typically aren't going to call directly. You'll usually do something like, dot notation calls get attribute, the bracket notation calls get item, len calls the Dunder. Well, actually, we haven't talked about that one, but Dunder, len, and so on. All right, so let's do an example real quick. Yeah. All right, so let's do. So what's going to happen when I try and run this?
I'm not certain with Python, but I think like a language like JavaScript would turn that integer into a string and just make it all a string.
Okay. So JavaScript will do some type coercion without telling you about it.
This is going to say like it can't concatenate a string and an integer together.
Okay. Python. So we get a type error. Unsupported operand types for plus, int and string. So we can't use this plus operator to do something to an int and a string. So Python is a little bit stricter than JavaScript in this particular case. But we don't have to let that stop us. So let's say we really like JavaScript. We really like this particular feature of JavaScript, and in our application, we want to be able to use this, the plus operator on strings and integers. So we can actually create our own class that does that. And we can create it in such a way that it behaves like a built-in Python class. We can do class. So I'm going to have it inherit from the built-in string. This is just a toy example, so you wouldn't necessarily, you probably would not want to inherit from a built-in type like this. Probably want to create an attribute or something that uses this and then kind of wrap it. But nonetheless, we can do this. So another weird thing, because I'm inheriting from the string directly, I'm going to have to call new. You can just basically ignore this part. All right. Give me something like this. And then if we try to print, we get ASDF. So this is, so far we haven't really done anything, but we are inheriting from the built-in string, and we're doing this, which you don't have to worry about. And so print, everything else works like normal, even though we didn't explicitly define an str representation or anything like that. We get all this stuff for free because it's inheriting from string, and string is inheriting from all kinds of other stuff. So this is all the stuff that we have. You can see all of these string methods and properties like is alpha, upper, is lower, capitalize, all this stuff from strings we're getting for free because we're subclassing. And then in addition to these kind of specific methods and properties, we also have all of these Dunder methods, which we shouldn't necessarily be calling directly, but mul, this is the multiply operator. And add is the plus sign. So we're going to want to customize this. We're going to want to customize the add. So let's go ahead and override. We don't want to use this built-in strings add because that's not going to give us what we want. We're going to have to do our own thing. So def so this first parameter self is like all instance methods. It's going to be the actual instance, and other is kind of conventional. It just means some other instance, right? So if I add, I do 3 plus 3. So 3 would be self, and other would be whatever the other one is. So all right, so S2. She won't even print it. So this plus sign, again, under the hood, Python is going to call this Dunder add method because that's just how Python does it. But now this custom, this custom string we have can behave like a built-in Python string. You can use the plus operator. We don't have anything else defined, but we could define, all kinds of other behaviors. So we could treat this like a built-in Python type. So instead of just printing something, we want to actually return a value. So what we could do is let's convert. Let's do so. Can try doing something like this. Do anyone have any guesses as to what might happen?
This is just going to concatenate them, so it's going to be like ASDF, FDFD.
Okay, it certainly could. So what is this operator going to call?
So that plus sign should call the def add that you created and create an infinite loop of print and then all the stuff that you're printing as it just keeps on returning that same thing over and over again.
Yeah, so that is a good guess. Let's see what happens. Actually, that should that should not have happened.
You kind of tricked it because you wrapped str around self. So
Okay.
it actually is, you're technically talking to the super class. But yeah, if you do that, it will infinite
I'm just too good.
recursion, maximum
That's my
recursion error.
problem. Okay, so this printed out, whatever, 999 times. And then we get a recursion error. So yeah, so this is calling the same thing over and over, because under the hood, this plus sign is calling this add. So this is not so important, but we can use string interpolation here. So we can do or what I had just done, this wrapping self in string. And then if let's assign this to value. And then we'll print it. So now we have our own custom JavaScript string in Python. So if you really miss JavaScript, you can implement this and use it everywhere. So that's it for the lecture. Is there any questions about that?
I'm guessing this will all start to make more sense about why you would do this when we start seeing it in context on a back-end server somewhere, because it just doesn't.
Yeah,
I understand what you're saying, but I just can't conceptualize when we would start doing this for functionality purposes, but I'm sure it'll come clear someday.
Yeah, it depends. It depends on the context, but a lot of it is just convenience. So instead of using this built-in add with the plus operator, we could just write our own. We could just write our own add method, like a normal method, right? Def add, and then something like whoops, oh yeah, B. So it'd be, we have to do self. So something like this. This would just be a normal instead of doing all this nonsense. We do, let's see. Do s dot add. Actually, I would probably just want to have one return self. Yeah. Let's try this. So this does the exact same thing, right? So I just have, my own custom method that I defined. It does the same thing, but maybe I want this to kind of, from like a user perspective or an API perspective, I want this to act like a normal Python object. I could, if you want that, if you want it to look like a Python object and act like a Python object, a built-in, then you can use the dunders to achieve that, or you can just write your own normal methods and do it that way. I don't know that, I mean, there are some cases where, there's kind of a clear answer, one or the other, but there are lots of cases where it's probably more just personal preference.
Thanks so much for explaining this information. Any other recommended references where we can find out more about Dunder methods? Any ideal recommended references?
Yeah, there's a couple in the README. One, actually, Chris has a tutorial, so that's linked in the today's README. And then there's another longer reference.